Understanding Common Graphic Design File Formats Part 2. Now, as we discussed in our last video of our Photoshop design course for beginners, Part 1, and we went over the technical specs and proper devices needed to run Photoshop. So, in this video, we're going to be going over file formats, common file formats for graphic designers. Now, as in other videos, I didn't want to make it a regurgitated laundry list of definitions of file formats because I don't think that's very helpful. I think that you guys are smart. You can Google what the definition of a JPEG is. However, this is going to be more in depth so you could really understand how this pertains to Photoshop, print, for the web, etc. Now, when I originally started this video, was to educate on the difference of DPI to PPI. And the more I dug through YouTube and the comments, I'm finding that people are really confused because they don't understand the basic file formats at all. I think design formats, probably this is the most confusing thing to even the most experienced designer. And because of this confusion, I just couldn't go straight into DPI versus PPI without first explaining the most common graphic design formats, and because it literally just wouldn't make any sense without doing so. Now, I want to clarify all this in depth, so I'm really excited to explain and really explain this thoroughly the correct way. And lucky for you, I'm going to teach you what I learned in college, plus you also have my 20 plus years of expertise, so you are definitely on the right video, photo, for sure. Now, this video is going to be very thorough, so it will be longer, so please make sure to take your breaks so you can sit through this. You can stop and pause the video at any time. I guarantee that you're going to learn tons, even if you are an experienced designer. I'm sure that you will learn something, and I want to make a bet with you guys. If you learn something, you have to subscribe and like and comment. If you don't learn diddly squat, hit the thumbs down and write in the comments as to why. So let's get to it. Many new designers out there just starting out, or non-designers, designers, whatever, they're confused at which file format do they choose. What file format should I choose though? No project is the same, so that is a tricky question. So before you can answer that question, you need to answer the following questions before choosing the right file. Which file format fits my specific needs at any given time? Is the file data accessible across all devices? Can the file be accessed quickly and seamlessly? Is the media within the file's top quality? So you're always going to want to use the top quality file, which produces the least amount of, I guess takes up the least amount of memory is what I'm trying to say. Also, before you know what file type to use, you will need to understand how they are used and understand the terminology. So we're going to define that terminology for the most common file types for designers. So let's get into it. What is a photo and how is it used? Photos are usually taken with either a camera or they're scanned in. To grasp the concept of the term high quality image in regards to digitizing your photos, you need to really comprehend how digital images work. Now, there are two main types of digital files: pixel graphics, which are raster, and object graphics, which are vector. Object graphics, otherwise known as vector graphics, are object-oriented, and these types of graphics are constructed using a mathematical formula describing shapes, colors, and placement. An object graphic can be enlarged to infinity without affecting quality. And it can contain an unlimited number of colors, and it doesn't take up a lot of memory. However, it cannot be used for photographic images. Some things that, vector object-oriented graphics are good for are logos, icons, newspapers, vector graphics, and illustrations are examples of some object graphics. Pixel graphics. A pixel is the smallest unit of a digital image or graphic that can be displayed and representative on a digital display device. Pixels are combined to form a complete image, video, or text, or any visible thing on a computer display. A pixel is also known as a picture element, and they're little tiny squares that make up a photo like a mosaic tiles. And these are usually what we refer to as raster files. Pixel-based images can be black or white or color or contain a different number of colors. So now that you know that there's the two main image file types, so let's talk about file formats. Every time you create a document or a graphic on the computer, the program then saves that graphic with a particular file format or internal structure. Some formats are raster, like on the left-hand side here, and some are vector. And some are high resolution and some are low resolution, as you can see here, lossy and lossless. Some are best for high resolution printing and some are excellent for low resolution printing, like I mentioned, web graphics. Some file formats can be translative devices to transfer a graphic from one program to another. So just as you wouldn't want to spend hours working on a file in the wrong program, you wouldn't want to spend hours working on a file in the wrong format. So let's go over all of these different types of formats. So there's two different types of file formats. It could be native or non-native. So a native file format would be specific to a program. So a native an example of this would be a PSB, that is Photoshop's large document format, and it is specifically only to Photoshop. So that would be a native file format. A non-native file format would be a JPEG, PNG, or GIF, because those are universal to pretty much any program can open them. Sometimes you can open native file formats in non-native programs, and sometimes they allow you to do this with the import function. Not all programs allow this, however, you'll have to basically look this up for each program. Okay, so as you can see here, I have this chart, and I'm not going to go through all of the definitions. I'm just going to go through the most important ones. But as you can see here, you do see that 8-bit, 24-bit. Now we're going to go over bits in detail when I do PPI versus DPI. If you look at JPEG on the raster side and JPEG 2000 on the vector side, wanted to tell you a little bit more about that because you're probably surprised to see that over there. A lot of people have heard of JPEG, but they haven't heard of JPEG 2000, or maybe you've seen it in Photoshop and wondered, what the heck is it? Well, JPEG 2000 was basically developed way ahead of its time when computers were only running about 64 gigabyte memory, and the larger file size of the JPEG 2000 just didn't seem economical for users because it was never widely adapted. Even though the JPEG 2000 is much better than its predecessor, the original JPEG file, the JPEG 2000 can be both lossless and lossy and retain less bit error and save files with less loss. And because of the image's complex coding system, it uses the state-of-the-art compression techniques. Technically, JPEG 2000 is raster format, but based on the technology, it can actually be both lossless and lossy, and is also comprised of a vector format. Now, you can read about the complex encoding which allows for this, and you can find out more about this at jpeg.org/JPEG2000 and take a look at its unique coding system. Now, the JPEG, which stands for Joint Photographic Experts Group, pronounced JPEG, is a compression format that makes images into much smaller files. The JPEG format is used for photographic images instead of a GIF format because in JPEG you have the full range of the 24-bit color. Now, which is better, JPEG or PNG? The PNG does offer a lossless quality, so it is better than the JPEG. However, when you get into the larger sizes, the JPEG is the winner in this one. Now, GIFs most people don't use GIFs anymore. They're usually used for like animation. So now the WEBP is an image format employing both lossy and lossless compression, and that's currently developed by Google. I don't think you will run into that file as much, but you should probably be aware of it. Now the TIFF. I really want to talk about the TIFF. TIFF stands for Tagged Image File Format, and almost every raster program, such as an image editing or paint program, can save as TIFFs. And almost every other application can open or import TIFFs. And the great thing about a TIFF is that it's extremely flexible. It can be CMYK, it can be RGB, it can be grayscale, it can be index or bitmap format, any bit depth, any resolution. TIFF is also the best format for files that need to go between Windows and Macintosh computer. And let me explain. So let's say, for instance, have you ever worked like in a design office where like your coworker has a Mac and you have a PC, or maybe you're working online, you know, like you're doing that whole home network thing. One time I had an issue where I was getting files from a coworker, and like every time like I sent him a file, it wasn't the same. It was just like weird because he has a Mac and I have a PC, and I just like refused to switcheroo. And so to solve that problem, what you would do is you would save it out as a TIFF. So when you choose to save it as a TIFF, you can change the byte order as either IBM PC or Macintosh. So a Mac can open TIFFs with the PC byte order, but a PC can rarely read or open a TIFF with a Mac byte order. So Adobe Photoshop or programs such as Adobe Photoshop or Equilibrium or Debabalizer Pro can convert files from one platform to another. So that's the great thing about TIFFs. You will rarely have problems with a TIFF file if you save it with LZW compression. Occasionally a file can't be opened by other programs, but if you get a TIFF file that can't be opened because of this, then what you're going to do is you're just going to open it back up in Photoshop and then save it back out without the LZW compression. The TIFF and EPS are probably, if you're doing professional work, those are the only acceptable forms of formats that you want to use for, you know, print. So with that being said, let's talk about EPS. Okay, some programs that use EPS, and I know freehand, Adobe Illustrator, CorelDRAW, they all use EPS, which stands for Encapsulated PostScript. The graphics in a vector EPS file are composed of a number of separate objects, each one defined mathematically instead of with pixels. A vector EPS file will print at whatever resolution is of the printer, and it can be enlarged and reduced with no degradation. WorkExpress and InDesign, and like if you're doing newsprint, or like I said, vector is good for the newsprint programs that support large print, basically. You can work back and forth with TIFF and EPS. So one of the examples is, like, let's say that you were creating a book cover in InDesign, and you had an EPS file, and you wanted to open that up into Photoshop and edit it, basically. And so what you could do is you could bring the EPS into Photoshop, rasterize it, because raster images, hello, and then save it out as a TIFF, and vice versa. There's many misconceptions about TIFF files, and one of them is that the layers will be flattened when saving. You can actually check the box saving the document as a TIFF to include the layers. You have a few different options. You have TIFF, and you have the PSD and the PSB. And I wanted to just basically give you the differences between those three. Now, they're not on this chart. Some of them are not on this chart, but I just put the basics up there. But I did want to explain the difference between TIFF, PSD, and PSB file limits. Okay, so the difference between TIFF and PSD, the only difference is that you can store larger amounts of information than the TIFF. The PSD file limit is 2 GB, and the TIFF can save up to 4 GB without loss. So The regular PSD can save 2 gigabytes and the TIFF can save 4 gigabytes without loss of data. So the TIFF can save more data than the PSD. So Adobe created the PSB, which stands for Photoshop Big, and it only works with Photoshop though, so that's the downside. So PSB files, the limit is 300k pixels by 300k pixels, any DPI. So I've created multiple files at 60 gigabytes using the PSB format. So, I mean, based, like if you did all the math and everything, it can handle 4.2 billion gigabytes. So that is a whole lot. So I don't think you will ever have a file that large, but it's crazy. So if we save this as a TIFF, so we're going to go File, Save As, and then we're going to go to TIFF, okay? And then when you press save, you don't think it's going to do anything, but this dialog box is going to pop up, okay? And you have a few options here. If you click this box, it's going to allow you to do that LZW compression thing I was talking about, where it reduces the file size, but you still retain the same amount of quality. And let's see here, you're going to be using PC, and you're going to leave it on interleave. And so here, if you click discard layers and save as a copy, it will discard the layers. This one here, it's a faster save and it saves bigger files. This one is a zip, it's slower save and saves smaller files. So we'll check that and press OK. Include layers will increase the file size. So as you can see here, it does save the layers. So if we go back out to the desktop, you can see that the TIFF is here. And we can open it back up in Photoshop, and the layers are still there. You can see that this is called copy.tiff, and we still have all the layers in our layers palette. Let's do TIFF versus RAW. Okay, so when we're talking about uncompressed files, we're also talking about lossless. So the TIFF and the RAW are both lossless, uncompressed format. That just means that the file contains more data and results in a more detailed picture. So basically, RAW is the equivalent of a digital film negative. The difference between RAW and TIFF, unlike TIFF, a RAW file first needs to be processed or developed using an image data converter such as Adobe Camera Raw or Lightroom or some other compatible software. The benefits of this format is that you can adjust the various attributes such as contrast, saturation, sharpness, white balance, and others without degrading the image. And then afterwards, it can be saved in another image format such as a TIFF or a JPEG. That's why photographers are always saying shoot in RAW. I just want to go ahead and get BMP and picked out of the way because they're just dumb and they're old technology, but you might run into them. Then there's the HEF files, which basically, this is Apple's new version of PIC files, I guess. So what the heck is a HEF file and why would you need it? A HEF stands for High Efficiency Image Format, and it's based on the Efficiency Video Compression HEVC, which is also known as H.265. And this format was developed by the moving picture experts group MPEG, and it became popular in 2017 when Apple announced that they were replacing JPEG files with HEF files in iOS 11. And compared to JPEG images, HEF images require considerably less storage without sacrificing image quality. There are 16 bits, and HEF also supports transparency, and the image colors up to 16 bits versus JPEG's measly 8-bit color. In practice, this means that a HEF can capture all the extended color range provided by the camera's 10-bit color output. So if an iPhone user shares an image with a non-iPhone user or to a social site, the HEF image is then converted to a JPEG image. If you do not want iOS to save images in the HEF format, open your Settings app and select Camera Formats, the most compatible selecting, and most compatible means that iOS will now save images in the JPEG format. So that is only pertaining to you if you have iOS 11. So if you wanted to know what that meant. I actually made a video about this going into detail, that I had an issue where on my phone my photos weren't being saved into 300 dpi JPEGs. They were at a very low resolution, and there were no settings that you could change to change that. You could change the video settings, but not the actual JPEG settings. And the only way around this was to actually install an app on my iPhone and basically take my images in RAW format and then bring them into Photoshop and then edit them and then save them out as a JPEG. So that is completely difficult, but yeah. Of course, the AI is the Illustrator document, so that is a vector document that you pull up in Illustrator. So you will often work with those files when you're working with Illustrator. SVG stands for Scalable Scalable Vector Graphic. I'm sorry. And so if I had to comparison, that would be like SVG would be versus ping. So ping is like the raster. We have this one in the raster ring, and we have SVG and the vector ring. Like, let's just do like versus. Okay, so basically SVGs are good for icons, web, you know, you can even animate them with CSS, all kinds of cool stuff. And a lot of people use them in Cricut machines, so I've heard. So the great thing about SVG is the resolution. It can be scaled to size, whereas pings can't. They're speedy, so because the file size is so small and they use less space, they're very, very, fast for the web. That's why they're used for the web. The practicality, there are many SVGs that can be used on the web for displaying logos, icons. They now have SVG fonts. So, all kinds of cool things that you can do with an SVG. So let's talk about PDFs. Maybe if you're viewing some kind of document on the web, there may be some incompatibility with browsers. You might have some incompatibility with file types, with fonts and stuff like that. So what a PDF does is it solves that problem. It doesn't matter which computer you use, what fonts are installed, the PDF will always look great and it prints great. So you've learned about pretty much all of the common file types for graphic designs. So now we're going to get into what is PPI and what is DPI. This is the most misconceivable. Everybody gets this messed up, even advanced designers. I actually had someone in the comments, when I was referring to an image, I said, the image quality should be at least 300 DPI. And he says, no, you mean PPI. And I says, no, I meant what I said, buddy. And here's why. First things first, let's define some things. Resolution is defined as how well an image is resolved, okay? If what we see is more smooth or clear in an image, then to us it's more resolved. It is what we refer to as high resolution, high quality HD, okay? So the first thing that you must understand is that the resolution on a monitor is very different than the resolution on a printer, okay? So therefore, the very short answer to this question is PPI deals with how your monitor resolves an image, and DPI deals with how a printed image is resolved, okay? Though PPI largely refers to screen display, it does play a small role in the print size of your design and thus the quality of the output. That's why it's confusing. However, let me explain, because we don't want to get size and resolution confused. Okay? We don't do that here. All right. Now, keep in mind that image size refers to the dimensions of an image, the x height and the length height. File size is about how much space an image takes up on your computer, like such as megabytes, gigabytes, terabytes. Okay? It is important to understand what the monitor is doing with the pixels. Pixels are picture elements, tiny little dots on the screen, and you have a fixed number of pixels on your monitor, and they are a fixed size. When you change the resolution on your Mac or PC, it does not change the number and size of pixels on your entire monitor. It will only affect how large or small things appear on your screen. It doesn't actually change how an image is resolved. Let me explain. Okay, so you know how you have an iPhone, you have a tablet, you have a TV screen, okay? So if I were to put the image on all of those devices, it would all appear the same way, okay? And that doesn't mean that the image that's displaying the picture has fewer pixels, okay? It's just changing how it's perceived. So when we talk about the resolution in terms of PPI, let me be clear. This is not what makes things look better on the screen. How well an image looks to our eyes and how things are resolved depends on how many colors a monitor can display, and this is the bit depth. Remember when I said I was going to talk more about bit depth later? This is that moment, okay? So what is bit depth? Bit depth is the number of bits used to represent a pixel, and it determines how many colors it can display. So an 8-bit pixel only allows for about 256 colors, while a 24-bit pixel displays like 16 million plus colors, okay? So it's a lot of colors. So what is pixel density? Pixel density determines the resolution of your monitor, and the apparent PPI of a monitor depends upon the screen's resolution. That is the number of pixels and the size of the screen and use of the monitor. So an 800 by 600 mode has a lower PPI than does the same monitor in a 1024 by 768 or 1280 by 960 mode. Let me explain. The subpixels inside, I mean, this does not exist in print, the RGB additive color model. That does not, these little subpixels, they don't exist in print. They only exist in electronic displays of images like television screens, computer monitors, and digital photography. So when you're talking about PPI, you're always referring to digital. Like the PPI is the measurement, it's literally the measurement of pixel density in an electronic display, okay? And DPI is the exact opposite, is the measurement of resolution used for printed text or images. The more dots per inch, the higher the resolution. I really hope you liked this video. If you liked it, please give it a huge thumbs up. If you learned something from it, let me know. If you have any questions, leave some comments. Thanks so much, guys.